Hello people, good afternoon. I want to introduce this laboratory. My name is Jung-hoon An and I'm in charge of this laboratory. The lab name is Microbioengineering Laboratory, and in this lab we are dealing with some bacteria to make some proteins. First I want to show you the proteins we are making here. These proteins is made by the 3D printer. This protein is the just model which is made by 3D printer, but in this laboratory we make real protein using the bacteria. So in this laboratory we are making different kinds of protein like enzymes and cytokines and growth factors, and also some useful proteins which is used in industry or the medical uses. This is called as PCR machine. You might heard of it because SARS-CoV diagnosis. This machine can amplify the DNA from the small sample. And if we obtain some DNA from the small sample, and then we can introduce that gene into the bacteria. This machine can introduce some gene into the bacteria using high voltage electric shock. It gives electric shock in short time, so the bacteria is not killed, but only DNA are inserted into the bacteria. And then if we have some bacteria which have the gene, then we are ready for the next step, protein synthesis. This machine is called as cream bench, and this is very useful for the bacterial experiment. If we turn it on, as you can see, you see you can hear the sound of air blowing. So the air blow out from the inside to outside, and every dust and every bacteria inside is removed from this room, and it is expelled outside. So this inside is very clean, and we can do some experiment without any contamination, without any dust.
Hello everyone, my name is Young Choi. I'm teaching chemistry in KSA. Today I will introduce my inorganic lab. In our inorganic lab, we are interested in some microporous and mesoporous materials, such as zeolite and metal-organic framework. Metal-organic frameworks are composed of metal joint and organic linker and make some many pores. Many pores can accommodate some gas molecules. And also zeolite also have a lot of pores. They also can accommodate some gas molecules. That's why they can be used as storage materials or electricity. To synthesize porous metal organic frameworks like this, usually we use fire or autoclave. Below 100 degrees we use fire, but at high temperature we use autoclave. At first we put the metal salt and organic ligand and solvent. We put all chemicals together and mix, and then we put the oven like this, and we have to wait. So after several days we can get some product. So it's metal organic framework. To measure surface area and porosity, we use this instrument. So in the bowl, we fill the liquid nitrogen. And then we are loading into the machine. It helps evacuating. After evacuation of some solvent from materials, and then we move to the sample part. So we analyze sample porous materials. Most of products are very small crystal with 0.1 millimeter. So we need microscope. Through microscope, we have to observe crystal.
Good afternoon. My name is Seonmi Park, a teacher of Earth Science of Korea Science Academy of KSA은 School. This mount is go-to mount. Go-to mount can move telescope automatically to the target and turn on the power of the mount and let it find the mechanical home like this. And then it can find the stars automatically and we can observe them while tracking them. This is the main dome observatory. It usually used for in-depth class, astronomy class and research program such as R&D program, graduation research, international collaborative research, and etc. The main telescope is 8-inch reflecting telescope and auxiliary telescope is 5-inch reflecting telescope. Main telescope can observe the object of magnitude 13. Turn on the power of the mount and we can control it with this hand controller and the Sky 10 program like this. It can move a telescope automatically to the target for observation. For stargazing, we open the dome and dome rotates 360 degrees.
Hello, this is Jung-gon Kim. I'm a person who in charge of this Dream Design Center. Dream Design Center is the hub of imagination and creative design at Korea Science Academy of KSA은. DDC is the perfect place for students to stretch their dreams by stimulating inspiration in a comfortable environment, allowing them to make their own product from initial idea with a variety of digitally controlled 3D equipment. This is Idea Conference Hall. Idea Conference Hall can help students make initial idea from the imagination in a comfortable atmosphere. In this room, workstation, tablet PC, Lego Mindstorm, and CAD/CAM software are prepared. Now we are in IoT and 3D printing lab, so students can make outside with the 3D printer. And also inside, we can make using the electric part over there. Usually we use the Arduino or Raspberry Pi. So we attach the sensor to the Arduino or Raspberry Pi to make inside of a product. So students can make outside with the 3D printer and inside with the Raspberry Pi or Arduino. So students can make their own product here. Now we are in Convergence Lab. Convergence Lab is for the space. We rent the table to the student because the student doesn't have any special place for their hobby or competition. So we give the chance to use this kind of a table for the students. And also they do their own work anytime in here. There are two kinds of electron microscope, SEM, TM. Our school has two kinds of electroscope both. This is the SEM. SEM meaning scanning electron microscope. Scanning electron microscope can observe outside of material. And also we have a TEM, transmission electron microscope. Transmission electron microscope can observe the inside of a material. This is MJP type 3D printer. This is a little bit advanced one compared with the other things. Using this 3D printer, we can make this kind of product. It can move without any support, like this. So someone who wants to moving parts, we can use this machine. We are in maker workspace here. While the students make a big product, they need a small part. When they want to make a small part, they can use this kind of a machine. We have 3 different CNC machine and laser cutter here. This laser cutter can make a cut out the metal. This machine we call lathe, make 2 axes. And there's a 3 axis engraver, and there's a 5 axis engraver over there. So when students make a big part, need a small part, they can use this kind of machine.